Hello students, this session we are going to discuss about the metrology of gears. After this session, the students can able to understand the various gear terminologies, various types of errors occur in the gears and the instrument used for measuring the errors. Before we step into the gears, metrology of gears, what is meant by gear? Gear is a rotating machine element which is used to transmit power within the short distance. For efficient transfer of speed and power, it is needless to state that gear should conform perfectly to the designed profile and dimension. So, the profile should be designed so that this will meet the requirement of the purpose. If any misalignment in the gears and run out which will not engage properly means which will produce vibration, chatter, noise and which leads to loss of power. So we will see the gear terminology. Center circle, center line is there. This is the pitch circle. This is the imaginary circle which is drawn to the um, gear. Above the pitch circle we have addendum circle. Below the pitch circle we have dedendum circle. Clearance will be there for the engagement of gear with pinion. So pinion is the counterpart for the gear. Then we have circular pitches there. This is the distance between two adjacent teeth. A single profile we are call it as tooth. We have more than one profile, that is we are normally known it as teeth. So this is the tooth thickness. That is the thickness of the tooth. Then this is the base circle. Then we have this portion is the portion here that is known as flank. These are the main terminologies in here. Then what are all the errors which normally occurs in gear so that we should avoid by measuring the proper measuring instrument and correcting those things. First one is gear blank runout error, gear teeth profile error, gear teeth errors, pitch circle errors, runout errors, lead errors, composite method of gear inspection, assembly errors. During assembly also some errors are encountered. So we have to be careful while in assembly also. So first one is gear blank runout error. Normally gears are produced by means of milling machine. In large scale we are going for casting or forging. After casting we are going for the preliminary machining operation to get the required outer dia and face. So the blank have the radial runout on the outer dia due to error in the preliminary machining. So while going for the machining, we have to take care of this profile to minimize the error. That is, runout error is known as the radial throwout of the axis of gear due to the out of roundness of the gear teeth profile. That is eccentricity in the pitch circle. That is small variation from the axis. So that we can measure by using two types. One is single probe check, another one is two probe check. This name implies that we are using only one probe, where the other type we are using two probes. Here we are having only one probe, that is known as single probe check. It is only one probe. Here only one probe is that which is connected to the dial indicator. The diameter of the probe contact with the flank face. This is the flank face. This is the center is the pitch circle. We have addendum circle. Outer circle is the addendum circle. So this diameter of the probe should contact with the flank face of the adjacent teeth. So this is the adjacent teeth. This probe should contact with the adjacent teeth in the area of the pitch circle. That is very important. It should contact with this area of the pitch circle, flank of the adjacent teeth. While we are keeping like this, now it is ready to take the reading from the dial indicator. So this is the single probe check. Next one is two probe check. So we have two probes are there. One probe is fixed, another probe is moving. These two probes are placed diametrically opposite to each other. Diametrically opposite to each other. Range of indication is more accurate when compared to the one probe check. Normally we have two probes, so that reading also accurate. This moving probe, other end is connected to the dial indicator. From that we can take readings as it is. So this is for measuring runout errors in gear teeth. One is single probe, another one is two probe. In single probe we have only one probe for measuring the runout errors, whereas two probe we have two fixed and movable probe. The next one is pitch measurement. So it is the very important phenomena when compared to the gears. It enables the measurement of caudal pitch between successive pair of teeth. So this distance is normally here call it as pitch. We have fixed finger and movable finger used to set two identical points on adjacent teeth along pitch circle. So this sets one tooth, another movable finger sets another tooth. So which these two fingers are contact with the pitch circle. So this finger is fixed, another one is movable. From that we can get the reading of the pitch. The next one is pitch checking instrument for measuring pitch. A pitch checking instrument is essentially a dividing head that can be used to measure pitch variation. So if we have variation in the pitch, we can use this pitch checking instrument. The instrument can be used for checking small as well as large gear due to its portability. So we can use it for small and large gears. Here also we have two probes. One is fixed, one is anvil. Another one is movable, that is the measuring feeler. Tooth flank is butted against the fixed anvil and locating support. So we have locating support and fixed anvil. So tooth flank is butted by means of this anvil and locating support. Here anvil opposite to the anvil we have counter support is there, that is connected to the dial indicator, and this portion is gear being inspected, and this is butted by means of locating support. Now this tooth is ready for measuring by means of measuring feeler. So this pitch checking process going on by means of this probe. It starts from pitch circle. So this reading is passed on to the dial indicator. From that we can check the reading. Next one is for measuring the tooth thickness. We have for measuring tooth thickness we have vernier tooth caliper is there. Then thickness is measured at pitch line. So this is the tooth thickness. So we have to take it in the pitch line. We have a horizontal arm and vertical arm. Horizontal arm for measuring pitch. From the figure we can easily notice that horizontal arm can be measured thickness of the gear tooth. Then vertical scale gives the caudal addendum. So we have a small formula to calculate the thickness and addendum. So this is the thickness. This is we have the tooth profile. This is the outer circle. We will call it as addendum. We have this is the pitch circle from here to here. This addendum. So this is the caudal addendum that is taken as D. This is the width of the tooth caudal thickness. So which can be calculated by means of this formula Nm sin 90 divided by N. N is the number of teeth, M is the module. Then one more formula for caudal addendum Nm divided by 2 open bracket 1 plus 2 by N minus cos 90 divided by N. By means of using this formula, we can directly calculate the tooth thickness and caudal addendum. The next one is measurement of lead. In the case of spur gear, lead tolerance is defined as the allowable deviation across the face width of the tooth surface. Here also we have the measuring pointer is there. This gives the reading. From that we can allow whether this gear is passed on the quality chip or not. Next one is gear measuring machine. This is the bed. In bed, this is a horizontal alignment. Vertically we have height adjusting hand wheel is there. In center we have measuring head, and measuring head is connected to the chart recorder, and the other end of the measuring head we have feeler. That feeler is just contact with the gear, and the gear is mounted to the work arbor and it is placed on the cross slide, carriage handwheel and carriage. So which blank we have to inspect, that is mounted on the work arbor. From that feeler is contact with the work blank one to being to inspect. So this feeler touches each tooth profile. From that we can get the reading from the chart recorded by means of the measuring head. Next one is composite method of gear inspection. That is Parkinson gear test. It is one of the popular gear testing machine used in metrology laboratories and tool room. The gear being inspected will be made to mesh with the standard gear. So standard gear will be there, master gear or standard gear will be there. That is mesh with the gear what we have to inspect, and a dial indicator is used to capture the radial errors. So it is the master gear being to inspect, which is mounted on the sliding carriage. Below the sliding carriage we have the scale. Then these all the things are mounted on the base. Under the base we have table. So this if any probleming meshes, that will be transferred to the sliding carriage and the dial indicator capture the reading. Next one is measurement with the tooth span micrometer. The micrometer is as good as inspection gauge and can be used to check errors for accuracy of span width. So span width, so it is a micrometer. We can measure the span width by means of this micrometer. Then here any measurement made by gauging the span of number of teeth will be constant. Here this is the pitch circle. So this is the pitch circle or base circle. This A C AC, which is tangent to this base circle. It is intersects B. So AC is one tangent, and A naught, A naught, C naught is that, and A1, A1, C1, A2, C2, A naught, C naught are equal, where A naught, C naught is the arc length of base circle. So here A naught, C naught, which is equal to A2, A2, C2, A1, C1, which is equal to AC. So in this A0, C0 is the arc length of the circle between the origin of the root. So these are all the some reference, NPTEL notes also there. These are all the some reference. This session gives overall view about the what are the terminologies used in gears and what are all the errors, normal errors which occurs in the gear, and what are all the measuring different types of measuring instrument they are used in the inspection department that we discussed in this chapter. Happy learning.